Welcome back, everyone. In this video, we're going to take a look at how WAN is set up. These are going to be primarily representing what we refer to as lease lines. These are direct connections between these devices. So you can consider the four LANs that I have right here. I've got a LAN over here, which is on network 201.110. I have a network here, 202.110. I've got one over here, 203.110, and one over here, 204.110. I just stuck to classful setups, and each of them has their own gateway, which are represented by these routers. What we like to do is to set up connectivity between all of these devices and enable routing so you can understand how a wide area network works. First and foremost, I would like to take a look at some of these. If I go to, say, this first PC, you can see that I have manually put in the address, and I'm assuming that the gateway address, which is this end right here, always ends on 10. So this being network 201, and this is 111, this is 112, I made the gateway address to be 1110. And that is the case for all of them. So for instance, if I look at this one, it's just one computer on this network is 203.111. You can see that the gateway address is 203.111.10, and that would be this end of the router. Now, currently, these are connected in their own local worlds. They can communicate locally, but there is no connectivity going across the network. Let's just verify that. If I open up the command prompt over here and ping 201.112, which is this computer down here, this should work with no problem. And you can see that we do have a reply. However, as of right now, we don't have connectivity to the gateway either because the router is still not up and running. Now, to go ahead and set up the connectivity over here, this is something that the phone company, a telephone company, or ISP would typically do. It's not something that an end administrator would necessarily do. Maybe an administrator for the ISP or the phone company, but not a corporation administrator. I'm going to open up this router and take a look at it. As you can see, these routers don't have any connectivity for serial connections or wide area connections. They have the Ethernet connections, but there is nothing right now. And you can see there are different types of modules that we can add to a Cisco router for the various types of WAN connections that we might need. Now, I cannot add connections right now. If I try to do that, it says that the router is on, so you have to turn this off. So I'll turn it off, and I will add two of these wide area interface cards. I mentioned this in a previous video, but just as a reminder that the way Cisco labels their ports, the device itself is considered device 0. If you have multiple devices stacked, then it would be 0, 1, 2, and it goes from bottom to top. And the bays are labeled from 0 to whatever you have. I have 4 of them here, so this would be 0, 1, 2, 3. And within each bay, because I have two connections, two serial interfaces over here, these are labeled from 0, again from bottom to top, right to left. So this port right here is serial 0 because the device is 0, bay 0, and itself is 0. And this one right here, for instance, is device 0, bay 1, and this is in position 0, so it'd be S010. Let me go ahead and turn this back on. I am going to add 2 of these to each of these routers. Let's turn it off and add 2 to this, turn it back on, close it, come to this one, turn it off, and 2 ports right here. I'm not going to necessarily use all of these. I'm just adding them just in case I need them. And let's go ahead and add 2 to this one. Now, once again, this is something that, your connections will be done by typically the phone company. Let me save my work in case something happens. So we have the serial ports connected. Now it's time to physically connect them together. Again, once again, this would be something that a technician would come to your place of work and make this connection. They would go and connect this stuff. And then they would either help you or tell you what you need to do to your resident router that you might have on premise to be able to communicate with their network. In this particular case, we are going to have these routers basically represent the various routers of the internet, or there could be various offices that we have computers in. I am going to pick this cable right here, which is a DCE to DTE cable. Think of the CS clock and the TS terminal. One end is the clocking mechanism, the other end is not. Again, the clocking is usually provided by the ISP or the phone company. In this case, we are going to provide the clock ourselves. So with this cable selected, I'm going to go to this router and I'm going to connect its serial 000. This is going to be the clock end because I clicked on it first. I'm going to connect it to this router's serial 000. I'm going to pick this again and click on this router. I'm going to connect it serial 001 to this router's 001. Now, they don't have to match. I'm just doing it so it makes it easier for myself, hopefully. I'm going to go and connect this router's serial 001 to this router's serial 001. And then I'm going to go ahead and connect this router's serial 010 to this router's serial 010. So you can see there are a lot of connections to this router. I'm going to go ahead and connect this router's serial 011 to this router's serial 011. I just made this up just so we have some connectivity between our various locations. You can see that I could have, for instance, connect this one directly to this one, but we have multiple paths. So a packet leaving here can go this way, it can go this way, it can go this way. So there are multiple ways for a packet to get from source to destination. And what's going to determine how that packet travels will be the routing protocols that we put in here in a little while. But right now we have full physical connectivity. There is no connectivity logically. There's no connection that's going from this end to that, and as far as the logical connection goes. I do want to point out that while these are their own LANs, each of these connections will also be considered its own LAN. So these are basically their own connectivity. These are point-to-point connections between these routers. I need to assign these some kind of a network, and to be efficient, I am going to basically do subnets here. So I'm going to go over here, put a little label. I'm going to take the network 200.110, and I'm going to subnet that. So I'm going to say, I will subnet this, and I'm thinking in my head what I'm going to do. I will make it a subnet of 28. Is that a good subnet? I can do better than that. I can probably do, let's think about this. If I had 256 minus 252, which is what I want, so that gives me 4 free bits that I need. So yes, 28 should be a fine thing. So this is what I'm going to do for all of them. Let me go ahead and let me just move this up here, and I will say subnet for the WAN links. So with that being the case, what I'm going to do is I'm going to come over here and make this end be 200.1.1, and the very first one is going to be 5, and this will have a mask of 255, 255, 255, 252. So this is going to be the 5 end. This end here is going to be 200.116. Let me just move it over so it's clear. That's this up here, and this one is over here. This end I'm going to make 200.1.1. Well, the next network is going to fall onto, let's see, 6, 7 is the broadcast 8, so it's going to be 9 at this end. I'm going to make this end be 9, which means I'm going to make this end be number 10. Now again, I have done a little bit of subnetting in my head, and hopefully I have not made a mistake. So this is 10. All right. I'm going to go over here for this one. I'm going to make this be 200, 1, 1, 11, 12. This is going to be 13 that I'm going to put for this end. I'm going to make this corresponding one be 14, of course. So 200, 1, 1, 14. And then this end, I am going to go to, let's say, 15, 6. So I'm going to make this be 17. And this end here to be 18. Just make sure it's very clear where these things are. And then I have these last two that are left. So let's go ahead and make this one after 18. You know what? I'm not sure if that is correct. Let me just double check my math here. So this is 5 and 6. That works. 7, 8. Then we go to 9, 10. That works fine. 11 is broadcast. 12. This is 13, 14. That works fine. Then I have network 16. That gives me 17 and 18. 19 is broadcast. This is network 20. So it looks like it's correct. So I'm going to make this be 21 and this end to be 22. This interface right here. Now all of these, let me make a note here. The mask will be 255, 255, 255, 252. Okay, so that's the mask that I'm going to be using for these addresses, for all of them. And you can see that if I do 256 minus 252, which is what I was doing a bit earlier, you get the number 4. So the first subnet, this is being done on the 4th octet, the first subnet is going to be network 200.114 with this mask. The first host will be 1 plus that, so it's network 5, and the second one is network 6. When you add another one, you go to, that's the broadcast, and then the next network is 4 plus 4, which is 8. So that's the next network, and that's this one right here with the hosts 9 and 10. The next one is 8 plus 4, which is 12, which is this one. Next one is 12 plus 4, which is 16, hosts 17 and 18. Hopefully you understand. But the physical connection at this point is done. We have physical connectivity. Just to make sure that this is not working, I'm going to open up this computer right here, open the command prompt, and I'm going to try to ping 204 here. So I'm going to ping 204.111, and this should fail as expected. We can see that it is not working, and that's completely what we expected. Okay, so let's go ahead and program each of these routers. I'm going to go by enabling the gateway addresses. So these are the Ethernet addresses. On these routers, they're gigabit Ethernet. And then after that, we're going to do each of the connections. For the purposes of this demonstration, I'm going to be using Open Shortest Path First, or OSPF, as my routing protocol. Other ones that Cisco uses that are popular are EIGRP and RIP. These are the two other routing protocols for routing traffic from one router to another router. So I'm going to open up this router 0 right here, go to the command line interface. I don't want to use the wizard, so I'm going to be at the router prompt right here, and I'm going to type enable. You can shorten it to just EN. Remember, you can always type a question mark to see what commands are available. What I want to do is I want to go to global configuration mode, so I can type config question mark, and the option that I have is terminal, so I can do terminal, press the tab key, which is what I'm doing, and it brings me to this. Now, I do want to point out I could just type in conf t, and it will work because it's not an ambiguous command. It knows how to complete them for us. In configuration mode of a router, we can program the router to, the interfaces, the routing, everything is done in configuration mode. I'm going to go to this interface right here, which is right now the gigabit 00. We can verify that if I just hover over it, you can see it's gig 00 connected to the switches gigabit 01. So I'm going to go to interface, and I can type it in, or I can type INT, press the tab key, and I can type gig, press the tab key, and this is 0/0. Once again, I could shorten it if I wanted to. Its IP address, as we remember, is 201.1.1.10 with a standard mask for class C. And in a router, they are shut down by default, so we say no shut. The shut command shuts down an interface. Everything in Cisco, if you wanted to do the reverse of it, you just put the word no in front of it. And you can see this starts to turn green, and this is being an orange amber, but soon it will become green too, which means the computers here now can see their gateway addresses, which is great. Okay, so that takes care of that. Now I have this interface right here. Let me hover over it. It's S0000, and this one is S001. So let's go ahead and take a look at those. So I'm going to type INT S000. That's all you have to do. I need to put this IP address in there, so I'll put that in. IP address 200.115. And we discussed that the mask is going to be this right here. I am going to say no shut to that. Now this doesn't come up yet because for serial connections both ends must be up, so once we enable this end it will come up. But remember, I made this the clock end, this router being the clock end, so I do need to put the clock rate in here, and I'll just put 2 million. No particular reason, it's a common rate to put in. So this address has been programmed. I'm going to go to this interface, which I believe was S001. Yes. So interface S001. And this one has the IP address of 200.119. Hopefully I'm not making mistakes here. 255, 255, 255, 252. And no shut. This is also the clock interface. I'm going to put clock rate 2 million. Now, if you put the clock command on an interface that's not the clock end, it's okay. It just will not accept it. It will tell you that you can't do it. So it's not that big of a deal. All this being done, I'll deal with the routing later. Let me go now to this router right here. It's a busy one. And let's go ahead and take care of this. Let's say no. EN to enable, and conf T to get into global configuration mode. Let's take a look at its interface, the Ethernet interface first, and I do want to verify that this is 00. It is. So interface GI00. You can shorten it to that if you want to. IP address is 200. I'm sorry, not 200. It's 201.1.202. Goodness. 1.1.10. Standard mask for class C, and that should come right up as soon as we say no shut, and it seems to be working. Very good. Let's take a look at these interfaces. Now this one is connected to 000 here, so interface S000, and it does need to be INT. Its IP address is 200.116. And I am subnetting there, so I put that in. And it is saying that you forgot to put address. So I'm going to say no shut. And watch what happens, because this end is already enabled. And when I do this, both of them should come on. You can see that both turn green. Now, this is not the clock end. If I put in the clock rate right here, this is what happens. It says this command applies only to DCE interfaces. With nothing, there's no harm done, in other words. Great. Now we want to move to this one. This interface is serial S010. Let's take a look at that. S010. IP address is 200.1.1.17, and it is being subnetted. No shut. This is a clock end, so I'm going to say clock rate 2 million. And that takes care of that one. Let's go to this interface. What was this one? S001. So let's take a look at that. Interface S001. Its IP address is 200.1.1.13. No shut. And this is the clock end, so clock rate 2 million. Great. We're done with this one. Let's go ahead and save the work. Let's move on to this one right here. Again, the command line interface. No, I don't want the wizard. EN for enable and conft for configuration via terminal. We're going to start with this one right here, this interface. Well, no, let me do this. Let me do the fast Ethernet first. So interface giga00. This IP address, this is network 203.1.1.10 as the gateway address, standard mask, and no shut. Ethernet ports do not require clock because they have clock built in, which is why I don't have to say clock rate. Looking at this, this is 001. So I'm going to go to interface S001. Its IP address is 200.1.1.10. It is subnetted, so we do that and we say no shut. This is not the clock in. I don't need to put any clocking in there. Let's take a look at this one. This one is serial port S010. So let's take a look at that. Interface S010. Its IP address is 200.1.1.18, 255, and no shut. Again, this is not a clock in. I don't need to worry about that. Coming to this guy right here, this is S011. So interface S011. Oops. And IP address is 200.1.1.21. And I say no shut. Now this is the clock end, so I'm going to put in clock rate 2 million. And we're done with this router. Let's go ahead and save our work. I'm going to come to this last router right here and go to the command line interface. No. Let's type in enable and configure from terminal. Looking at this interface right here, I have S011. So interface, well, I'm sorry, let me take a look at the gigabit first, gigabit 00. And we're on network 204 here. So I'm going to put in IP address 204.1.1.10. Standard mask for that one. No shut. And once again, looking at this, it was 011. So interface S011. And its IP address, as I have it marked, is 200.1.1.22. It is masked and no shut. None of these are clock ends at this side, so I don't need to worry about that. Lastly, this interface right here is S001. S001. IP address 200.1.1.14. And no shut. And I will save this. So we have a situation now that we have complete connectivity throughout. So the physical connectivity is there. All the lights are green. This is great. But we still can't ping the far end. So if I go to that and try to ping 204.1.1.1, which is this one right here, you will see that it makes it now to the gateway before it was even getting to that. So it's making it all the way to here, but beyond here, it can't go anywhere, and it comes back saying destination host unreachable because the routers are not programmed to do any routing right now. So let's go ahead and do that. And as I said, we are going to use OSPF, using OSPF for routing. And I'll put that down here. Start with this first one. And I'm going to go, I'll type exit just so it's a little bit cleaner. And to do OSPF, you type router OSPF. If I just do that, it doesn't like it. It says it's an incomplete command. Well, what are you looking for? It's looking for a process ID. Now, this is internal to the router, and it's a locally significant number. In other words, OSPF number here and OSPF number here do not need to match. Just for your information, if this was EIGRP, then it would be significant that they have to match. So I'll just give all of them the number 1, just to make it easy. So now that we have this, what we have to put in are the networks that this router is responsible for. So I'm going to type in network, and the first network is the LAN, which is 201. And notice these are network addresses. They're not host addresses. What the router also expects is not a mask. What OSPF uses in Cisco world uses what's called a wildcard mask. Now, to calculate a wildcard is very easy. We know that our subnet mask is 255, 255, 255, 0. You simply do 255 minus n every single octet. So 255 minus 255 is 0. So this first one will be 0. The next one is also 255 minus 255, which is 0, 0. And then 255 minus 0 for the last one is 255. And these are all going to be in the single area, area 0. So that's what you put in. So this is the first network that this router is responsible for. I'm not going to get into the various areas. Area 0 is called the backbone area. There you can have multi-area setups with OSPF, which is, by the way, quite normal. But as I said, this is not a Cisco class. This is not anything like that. I just want you to understand what a wide area network is like. Looking at the others, I see that I have a network here and a network here, so I'm going to put in those networks. You know, that's 200.114 is the network. The subnet was this. So what's 255 minus each of these? Well, it's going to be 0, 0, 0, and 255 minus that is going to be 3. So I'm going to put in 0, 0, 0, 3 and area 0. Also network 200.118, which is this one down here with hosts 9 and 10, and it has the same wildcard mask. And we're done with this router. Let's save our work. Moving on to the next one, Busy Boy. I'm going to type in exit, and I'm going to type in router OSPF1. Let's take a look at this one. This one has the Ethernet network 202.110, wildcard mask. It has network 200.114, so network 200.114, and the wildcard mask is this. It has network 200.112, same wildcard mask, and you can see that it's establishing relationships, and it kind of cut me off, which is not a big deal. So that's this one, and we have this network right here, which is network 200.116 with hosts 17 and 18 being there, area 0. So this takes care of this router at this point. Let's save. Let's come to this one. This is also a Busy Boy. Let's exit and type router OSPF1. Now, as I start putting these in here, because the other ends have been programmed, you're going to see this pop up saying establishing adjacency. So I'm going to go to, first of all, network 203 with a wildcard mask. Network 200.118. And the wildcard mask, as you recall, is this one when you do your subtractions. And this is going to pop up with some adjacency right now. Let's wait for it. And there you go. So that's taken care of. And then I have this one, which is network 200.116. Area 0. And this is going to pop up with a adjacency in just a moment. There you go. We have this one left. So this is network 200.120. The other end is not set up, so nothing's going to happen right now. We need to go to this last router. Let's go ahead and close this. Open the last router. And I'll exit. I will do router OSPF1. So this one is responsible for network 204.111. So let's put in the Ethernet one, network 204.110. That takes care of that. And then I have networks 200.112. And there's a wildcard. Now notice that this is going to pop up again. It's going to say loading is done. And lastly, this network, which is network 20. Network 200.120 with the wildcard. And you're going to see that this will pop up in just a moment. And the loading is done. So assuming that I've done everything correctly, we should have complete routing enabled throughout this network. If I bring this back up and look at the command prompt, do an up arrow to try to ping. And remember, I'm on 201.111, which is this one. I'm trying to ping this one right here. Let's see if it works. And you can see that the pings are in fact going through. Now, just for the sake of being complete, if I were to look at this router right here and type in exit and type in show IP route, this is the routing table. It tells us to go to network 204. We can find 204 right here. It says you're going to be using OSPF. We can see in the legend that O is for OSPF. This is the administrative distance and the the metric, which I'm not going to go over right now. But the administrative distance for OSPF is always 110. And the metric is calculated based on bandwidth and other factors. It says to go to 204.110, which is this far network right here. You need to go to 200.116, and to get to that, you need to go out of serial S000, which is this interface right here. It has also discovered that there's an equally viable path. So you can either do this, or you can go to 200.110, and you get to this by going out of serial S001, which is this interface right here, if you take a look. So this is what the routing OSPF that's doing. This is what the routing protocol is doing. I'm not sure why my interfaces are not popping up. There you go, S001, and this one is S000. There you go. So it's telling you exactly what it needs to do. Now, all of these routers have their own routing tables, and as changes occur, these routing tables become, they update themselves. For instance, if I were to go ahead and kill this connection right here. By the way, before I do that, I do want to take a look at how do we get to network 203. Well, to get to network 203, it says you go out of 200.110, you go to this, you get to this by going to this interface right here. Now watch what happens if I kill this one. So this network was just destroyed, that connection. So coming over here, you can see that there was some change done. Now if I do show IP route again, now to get to network 203.110, you're no longer going out to 200.1.1.10 because there's no direct connection. It says you need to go to 116, and you get to that by going out of S000 because it knows if it sends it here, this router will be able to forward it to this router. You also notice that the second path to 204.110 to that network is gone. There's only a single path at this point. So this is very dynamic. I'll bring it back. I'll just connect it, and I think it was 001 to 0001. I'm pretty sure that's what it was. And if I bring this back up, you can see again that it is updated itself, and we're back to the situation that we had. Nope, it hasn't updated. Now it finished updating, and we should see a second path appear here. I'm not quite sure why it hasn't come up yet, but it will come up at some point. So I can see to get to 204, it says you need to still go to 6. Let me try this again. And there's the second one. It just appeared. So as you can see, it updated it. There is a bit of a delay. It's not that much. It's just a matter of some seconds, few seconds, but it does update itself. Well, I'm going to stop it right here. I'm going to have another video where I, instead of having direct connections, these sort of leased lines, we're going to take a look at using a shared connection such as frame relay to illustrate the concept. But hopefully this is clear now as to what a wide area network is all about. Wide area networks, you have wide area network setups. In this case, we have serial cables versus Ethernet, which is used primarily for local area networks as of now. There are talks of having Ethernet also be designed for wide area network. I hope you enjoyed this video. If you're liking these videos, please share with loved ones, and I'll see you in the next one.